partial reflection and refraction. So in this case, reflection and refraction both will take place, as you can see in the diagram. Now you can see here, there is a water and air, both are transparent media. The light is incident towards the water surface. Part of it is reflected, that is, reflection is taking place. The other part has gone inside the water. It is bending towards the normal. So the reflection and refraction both have taken place simultaneously. Okay. Now, when this water is replaced by glass, what change can you see? You might see reflection has taken place. The refraction, it is even more, because glass, the density is even more. Now if you replace the glass with diamond, the bending will be even more. So there are many examples where you can see reflection and refraction. One more example which I can give, in our classroom we have cupboard has glass. So if you see what is kept inside the cupboard, you can see reflection as well as refraction. Reflection means you can see your own self, also you can see what all things are kept inside it. So reflection and refraction most of the times will take place simultaneously. These are many examples. You can see someone is swimming inside water. You can see part of that is reflected, part of that is refracted. Again, in goggles, if you see, sometimes you can see the ice, sometimes you can see the light is getting refracted and reflected. See, you can see, I can give few more examples. On left hand side you can see one, there are the architectural work which was done long back, around 15-20 years back. It is called as Don't Miss a Second. It is installed at a construction site across London's Tate Britain Museum. Okay, this is actually a glass, but because of reflection, many people, what they do is, you can see there is a public toilet which is enclosed within the reflective glass walls that allow the users to see out but prevent them outside. Means what? If you are inside it, you can see the outside world, but outside world cannot see you. So it will be so scary, because inside we have is toilet. So whatever thing you are doing inside, right, while doing it, you can see the people outside, but the others cannot see. So it is actually an example of partial reflection and refraction. It's beautifully made. It is an artwork. You know what is speed of light? Speed of light is 3 × 10⁸ meter per second. It is impossible for any particle to move with the speed of light. But the speed of light that was in air or vacuum, when it enters water or any other transparent medium, the speed changes. You can see the speed of light in water, it is 2.6. In acrylic, it is even less. So the speed is getting reduced. As I said, in diamond, it is 1.23. It is even less than the acrylic or glass or water. Because the bending, as bending increases, the speed will be less. So sometimes they will ask you the factors on which refraction is dependent. Refraction is bending. So it depends on what? It depends on angle of incidence. Means with the angle with which the light is incident, it also depends on the color, that is the wavelength. Because if it is violet, the refraction is more. If it is red, refraction is less. It also depends on the material. Is it diamond? Is it water? Is it oil? Is it glass? In glass also there are different types of glasses. So on various factors it depends. So as we saw, the refraction depends on the speed. So we will study the next concept, that is called as index of refraction, also called as refractive index. So So refractive index of any material means you are relating the speed of light in air and speed of light in that material. So refractive index is denoted by that n is called as eta. Eta is c by v. C means speed of light in air or vacuum. 2 speed of light in that medium. You can see in numerator you have speed, in denominator also you have speed. So speed and speed will get cancelled. So it does not have any unit. So refractive index of any material will always be greater than 1, because the denominator will always be less than numerator. So the answer will always be greater than 1. The least is of air, that is 1, other is greater than 1. So what is the definition of refractive index? It is the ratio of speed of light in air or vacuum to speed of light in that particular medium. It does not have any unit. These are few of the refractive index. Vacuum is 1. Air is 1.00003, which we will take it as 1. It's a round figure. Then ice is 1.31. Water is 1.33. Quartz is a type of stone, it is 1.46. Glass is 1.52. There are different examples, around 15-20 examples even in your textbook. The questions generally students ask is whether we have to memorize it. I would say no, don't memorize it. Just 2 values you have to memorize. That is the first, speed of light in air or vacuum. We'll consider air and vacuum both are same, because the refractive index is almost 1. And that of diamond. Please ignore gallium phosphide, it is not there in your syllabus. So we will say diamond, it is 2.42. Just 2 you have to remember, 2.42, and air, that is 1. In your textbook it is given 2.41. It is okay, 2.4, 2.41, 2.42. It is, they have just they've taken the third digit after the decimal, and then they have just rounded off to get it as 2.42. Clear? So with this we can say that the speed of light will be minimum for diamond, and hence the bending will be maximum for diamond. Let us see one example. It says that the speed of light in sample of glass is 1.91 into 10 raised to 8. The speed of light in vacuum is 3 into 10 raised to 8. What is the refractive index? So the speed is given in 2 cases, that is of glass and vacuum. We have been asked to find the refractive index. Okay. So C is given 3 into 10 raised to 8. Speed is given 1.91 into 10 raised to 8. You will simply use the formula of refractive index. What is required is N, that is refractive index. The formula for that is C by V. So 3 into 10 raised to 8 meter per second upon 1.91 into 10 raised to 8. When you divide it, 10 raised to 8, 10 raised to 8 get cancelled. You will get 3.00 into 1.91. You remove the decimal by multiplying by 100, you get 300 by 191. You do long division, you get the answer as 1.57. Remember, there is no unit. There is no unit. Reason being, it is the ratio of same quantity. So the answer is 1.57. Next sum, what is the speed of light in water given that the water has refractive index of 1.33? Now the refractive index is given, nothing else is given. You need to find the speed of light in water. We know that refractive index is C by V. C is speed of light in air, which is 3 into 10 raised to 8. Even if you don't know it, please try to know it now, because in further chapters we have to by heart the value. 3 into 10 raised to 8 meter per second. So you use the formula C by V. You get 3 into 10 raised to 8 upon 1.33. My suggestion is do not touch this 10 raised to 8. Let it be as it is. When you divide 3 upon 1.33. First thing is you will have to remove the decimal. You will multiply by 100 in numerator and denominator. You will get 300 by 133. You take a long division method, you get 2.26 into 10 raised to 8 meter per second. Unit, you have to find the velocity. Since velocity is asked, your unit will be meter per second. Okay. Now we will see the next topic, that is Snell's law. Do you remember what are the laws of reflection? Laws of reflection: incident ray, normal and reflected ray lie on the same plane. Angle of incidence is equal to angle of refraction. We have studied this. So what are laws of refraction? First law is very similar. Incident ray, refracted ray and normal lie on the same plane. Okay, so that is the same. There we said reflected ray, here we would say refracted ray. There we said in reflection we said angle of incidence is equal to angle of reflection. But here we saw that it is not the case because it bends, so the angle changes. So the second law is sin I upon sin R is constant. This law was given by a scientist named Snell. Hence the law is called as Snell's law. Sin, cos, tan, cosec, sec, cot you have studied in mathematics, that is trigonometry. Now there are few students who have not taken mathematics. For them I am explaining. There is something called as trigonometry. We have seen sin, cos, cosec. Here we are using sin. Now just see the red light which is coming towards the water. Part of that is reflected. We are not interested in that. Part of them is refracted. Means what? It has gone inside the water. You have to see the angle of incidence and angle of refraction. Angle of refraction I have denoted by capital R. Angle of incident by small I. What Snell said? Snell said the ratio of sine of angle of incidence to sine of angle of refraction will always be constant. Means here if I is 20, R is 15. When you find sine of 20 and you divide by sine of 15, say you get the answer as 1.5. Now if you change the value of I, the R will also change. But if you find the ratio of sine of I and sine of R, you will get the same answer, that is 1.5. It will always remain same for a given pair of media. Here the media is air and water. It will always be constant. I repeat, you just have to understand. No one is going to ask you the explanation. If I change the value of I, the value of R will also change. But if I find the value of sine of both the numbers, you can just use calculator to find the sine value. Nowadays in every phone you have the function of sine, cosec, cot and everything. If you find sine of that angle, whatever I you have taken, you find the value of R, you find sine of it and you divide it. You will get some value, that is say 1.2. Now change your I, change your R, again you will get some value. You divide it, you should get 1.2. It will always remain constant for given pair of media. That was given. Now the question is, given the diagram below, calculate the angle of refraction and draw the refracted ray. What you have to draw? You can see the light is going from glass to water. So that is angle of incidence. You have to find. For that you will draw a normal. What is a normal? It is a line which is perpendicular to the surface. So at that arrow you will draw a normal. You can use the protractor to find the angle. You will get some angle. Right. Let that angle be 20 degree. Now use the formula. What is the formula of Snell? Sin I by sin R is equal to constant, that is refractive index. So you find the value of sine, say our angle is 30. So sin 30 upon sin R is equal to 1.52. Use that formula, find the value of sin R. So you will get some value. So the R will be reciprocal of it. Okay, the reciprocal of that is sine inverse of that number. So if you use the calculator, this is just for your you can do this experiment at your home, or in our school we can do it. In exam they won't ask you that number, because in trigonometry also you have found what the value of 0, 30, 45, 60, 90, that's it. You have not found the value of say sine 26, sine 25, sine 30. So you need not bother. Fine, you need not worry about that. You will get simple values. Even if they give you some difficult number like 26, they will mention in the question like sine 26 is this much. Okay, so we end the lecture.